Let's look at one more optimization question. A Norman window has the shape of a rectangle surmounted by a semicircle. Thus, the diameter of the semicircle is equal to the width of the rectangle. If the perimeter of the window is 30 feet, find the dimensions of the window so that the greatest possible amount of light is admitted. There's a lot of information here. So from the last piece, so the greatest amount of light is admitted. That means that they want the biggest possible area for the window. Bigger window, more light. The Norman window design, it means that it is a semicircle on the top. So this part right here is a semicircle, which is half of a circle. And that is mounted on top of a rectangle. So what we know is that the diameter of the circle right here is equal to the length of the rectangle. And that's, well, they say the width right here, the width of the rectangle. And that's what this piece in parentheses means. Thus, the diameter of the semicircle is equal to the width of the rectangle. So that's what that's telling you. If the perimeter of the window, so the whole window itself, the perimeter is the whole outside, this piece right here that's connecting the semicircle and the rectangle, that doesn't count as part of the perimeter. If the perimeter of the window is 30 feet, find, and then basically we want the biggest window possible. So the perimeter of the window, how would we write the perimeter of the window? Well, the perimeter of the window is the whole outside. So half of a circle from up here, and then 1, 2, 3 sides of our rectangle. So that's going to be the perimeter of our window. So let's see if we can figure this out. The perimeter is going to be half of our circle plus 3 sides of our rectangle. All right, so let's put in some values here. We're told that this bottom dimension is x. So let's call this vertical dimension y, and let's see what we've got. So the perimeter is half of, we need the perimeter of a circle. The perimeter of a circle is pi times the diameter, pi d. Well, the diameter right here is x. So we have half of pi x in this case. And then we need to figure out our 3 sides. Well, one side is just x from right here at the bottom. And then we have y on the vertical and y on the vertical. So 2y plus x. You could have done x plus 2y. That doesn't change anything. It's all the same. So let's see. How can we solve this down? Well, we could solve it for x, or we could solve it for y. Is one better than the other? That's kind of an opinion question. I think I'll just solve it for y. Take your pick. Either way will work. Before we try to solve it though, let's put in our 30 right here for our perimeter. All right, so we're making some progress here. So this looks like we'll have 30 is equal to pi x over 2 plus 2y plus x. So if I move this pi x over 2 and this x over, so 30 minus pi x over 2 minus x, that'll leave me with 2y. And if I divide this whole mess by 2, that'll be 30 minus pi x over 2 minus x all over 2 is equaling to y. All right, well, we can work this out. 30 over 2 is 15. Pi x over 2 really becomes pi x over 4 because you would flip and multiply. So it would look like, let me show you, pi x over 2 all over 2 over 1. So we would take this bottom right here and flip and multiply. So that would be times 1/2. And then that's where we get our pi x over 2 times 2 gives us 4. So minus pi x over 4. And then let me clear this out of the way from our scrap work. We have still this right here, minus x over 2. So that can become minus x over 2 is equal to y. All right, well, we got something. So let's see what we can do from here. So we want to have the greatest possible amount of light. So we want the area to be maximized. So let's see, what is our area? So area is half of our circle, so half of pi r squared, plus the area of our rectangle, which is x times y. All right, what can we put in here? Well, what is the radius? Well, the radius would be from here over. So it looks like our radius would be half of x, or x over 2. So if we put this in, we have 1/2. We have pi. We have x over 2, and that's squared. Plus x we still have as x. And y, remember, we simplified down here. So 15 minus pi x over 4 minus x over 2. There we go. It really doesn't look much more simplified, but at least it's a start and we're getting somewhere. Let's see if we can clean it up a little bit before we try to take the derivative. So there's not as many pieces. So here we would have x squared over 4 times 2 would be 8. So this looks like pi x squared over 8. All right, let's try the next one. We can distribute this x right here. So that looks like 15x minus pi x squared over 4 minus, looks like x squared over 2. You could go through getting these two pieces right here to have a common denominator with our pi x squared over 8 and our pi x squared over 4. I'm not going to worry about it. I'm just going to do the derivative and take care of that first, and then see what I need to do to simplify. So let's take our derivative. So our derivative would look like, bring down your power. So 2 pi x over 8. And then plus derivative of 15x is just 15. Then bring down your power, so 2 pi x over 4. Bring down your power, 2x over 2. Now there's a lot here I can simplify. This 2 over 8 can become 1 over 4. 2 over 4 can become 1 over 2. And 2 over 2, that can cancel. So let's try again. So a prime, our derivative, looks like it is equal to pi x over 4 plus 15 minus pi x over 2 minus x. Take your derivative, set it equal to 0. There we go. Well, let's see if we can combine these two together now. So if I need a common denominator, that would make this a 4. To get a 4, I need to multiply by 2. So there we go. So that looks like it'll be 2 pi x over 4. So that's going to give us 0 is equal to 15 minus, we have 1/4 minus 2/4. So minus pi x, so minus 1/4, so just pi x over 4, and then minus x. I've got to get this to factor, or I've got to get it so that we can have set equal to 0. So I'm going to pull out, I see a minus x right here and right here. So I'm going to pull out that minus x. So that will look like 0 is equal to, let's see here, let's pull out an x. I won't worry about the negative. I'll just leave it for now. You could pull out the negative, it will work as well. I'll leave it. And so if I pull out an x from these two pieces right here, what will we have left? Well, let's see. Negative pi x. Oh, we put out the x. So negative pi over 4. And then negative x would just become negative x. Now don't forget, we still have this 15 hanging out in the front. I'm going to put it to the back. You could put it in the front. It doesn't matter. Now our goal is to solve for this x. So if we subtract our 15 over, we'll be left with x times negative pi over 4 minus, whoops, look at that. I factored out an x and I wrote the wrong thing. So from right here, we're pulling out an x, so it should be minus 1. See right here, it was minus x. We pulled out an x, so minus 1. So now we need to divide it. So that's going to look like negative 15 divided by negative pi over 4 minus 1 is equal to x. Remember, we're trying to solve for x. So now we have this whole big mess and we need to type that all in and see if we can solve it down for x. When we divide this all down, make sure you're okay typing it into your calculator. I would do the bottom part first, get a value, save the decimal, and then do negative 15 divided by that. But when you type this all in, you should get 8.401, and our unit would be feet. So that is just figuring out x. We need the dimensions, so we need x and y. Well, if you remember, we had our y equation all the way back over here. Usually I would put it back into the higher up equation so we can solve it down. This one's kind of messy, so I'm going to go ahead and put it back in right here into the y. So that's going to look like 15 minus pi times, what did we have, 8.401, that's our x, all over 4, minus 8.401 all over 2 is equal to y. And when you type all that in, be very careful typing it all in. You should get, I am fresh out of space here. Let's see, you should get y is equal to, I'll squeeze it in, 4.201. And it would be feet. So sorry that one is sort of squeezed in right there. But what we were doing is we found our x value of our 8.401 feet. We substituted it back in and we found our y value of 4.201 feet. So these are the dimensions that will give us the largest possible window.